Assalamualaikum and hello everyone. My group members and I will present to you about our project, which is Model Bridge Design. My name is Nur Izzati Nabila binti Roslan and I will present to you about the introduction of this project. Bridge is very important and beneficial to everyone since it allows a two-way travel even though there are rivers, lakes, sea and gorge under it. Therefore, bridges should have a good features which is strong and quality, durable and cost-effective. There are six typical truss used for bridge, which is Pratt truss, Parker truss, Warren truss, Howard truss, Baltimore truss, and Key truss. This is the two-dimensional drawing for truss. As for this project, we choose Warren truss because of its design, load, and cost. For the design, it contains only equilateral triangles, so it can be easily identified and it has the ability to distribute the load evenly to all the members despite of its simple design. It is also low cost since it uses the least amount of the members. This is the model dimension and structural specification for the project. The length for the model is 10 meter and the base area is 2 times 2. The clear span between the supporting abutment is 6 meter and the height for the model is 3 meter. The uniform distributed load is 1.96 kN per meter and the size for I-beam for all members is universal columns 305 times 305 times 283 millimeter. That's all from me. I will pass up to my group members. Thank you.
Hi, my name is Nur Shazlina Matima Anwar, metric numbers 190271. So today I will discuss about the software calculation using Pro 27. For the support, we use support at 2 meter from the front is pin, and then the roller at 2 meter from the backline of bridge. This is roller and this is pin. And we apply distribution load on bridge is 1.96 kN over m for overall length of bridge, which is the blue line. And then for the materials, we use bamboo stick for our bridge, and this is the value for modulus of elastic, which is 1045579.5.20. The thermal expansion alpha is this, and the cross-section area, which is A, equal to 1.500 E minus 10, and this is the value of moment of inertia. And then for the result, the support reaction at each support is 9.80 kilonewton for each support. And the deflection is 0.00001 at the middle of the bridge. And for the internal forces at each member, the red color is for tension and the blue color is for compression. And this is our result in using Pro 27 for internal forces of each member. And this is the value, the details value for each member. We can look at 0 to 1 is negative 0.42, which is compression, and 1 to 2 is 0.24, this is tension, and so on. Thank you.
Hi, Assalamualaikum. My name is Inshida, and now I'm gonna present about the manual calculation of this project. Okay, first, we need to draw the free body diagram of the one truss. It has 10 meter in length, 3 meter in height, and has a uniform distributed load among the beam, which is 1.96 km per meter. Okay. Next, we need to calculate the determinacy, either it's statically determinate, statically indeterminate, or unstable. So, we know it has 19 members, 3 sections, which is 2 on pin and 1 on roll support. And it has 11 joints, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Substitute this number into this equation, which is member plus reaction equal to 2 times joints. And you will get 22 equals to 22, which is statically determinate. Then, you need to calculate the reaction support on pin and roll support. As you can see, this is the result. Fax equal to 0 as it has no reaction acted on as exits. Fb1 and Fa1 we get 7.84 kilonewton. Next, we need to convert the uniform distributed load to point load, which is 1.96 multiplied with 10 and divide to 6 joints. So we get 3.27 kilonewton for every joint, which is joint C, joint A, joint F, joint H, joint B, and joint K. Okay, this is internal force in this system using the inspection method. As we can see, joint AP, joint AO, joint BM, and joint BL has compression in it. Meanwhile, the rest are in tension. Okay, next. This is internal force using the virtuous system, as we put only 1 kilonewton on joint N. So the result is we have 3 types of member, which is zero force member, compression, and tension. CP, SC, AK, and KL is a zero force member. Meanwhile, AP, AO, OF, FN, HN, HM, BM, and BL is compression, and the rest AF, FH, HA, LM, MN, NO, and OP is in tension. So, this is the comparison of the internal force in the real system and the virtual system. So, next, we need to tabulate the data and find the sum of the real system multiplied with the virtual system and its length. So, we get 4.38. Next, okay, then we substitute all the data given into this equation, which is 1 times the deflection on joint N vertically, and we get the answer is -1.
Hello, my name is Fatina Najwa. So now I will explain about the recommendation. First is reinforced concrete or RCC. Concrete is important material in the construction bridge because it is able to provide a high level of flexibility. This is able to make it perfect to absorb the entire load and weight distribution that acts on it. The use of this concrete allows engineers and architects to develop various forms of particle structure. Therefore, our group is recommended to use of reinforced concrete in this project. RCC able to increase the ductility of the concrete. Concrete has a coefficient of heat development similar to steel when it is able to help in the loss of internal stress due to shrinkage and expansion. The use of stone has been used the centuries in the structure of. Next is granite stone. The use of stone has been used for centuries in the construction of the bridge. Bridge built of stone has among the strongest and most durable type of bridge. The use of stone facilitates the construction of a bridge and is able to increase aesthetic value. Furthermore, the use of the stone promotes the environmental sustainable, where it is readily available and does not require initial heating or major renovation of this bridge construction. The last recommendation in this project is damper and flexible material. It will allow the bridge to bear more loads by placing damper in the construction of the bridge, because it will protect the bridge from any unnecessary load and absorb vibration from any movement caused by any moving person or cars or maximum load using this bridge. In addition, the bridge that will be constructed must use flexible materials so that the bridge can still support it without collapse when there is excessive load. So for the conclusion, in order to provide sustainable design service as bridge planning, it is important to develop a comprehensive understanding and knowledge of the type of bridge and is constructing using exciting construction technology. This project is designed to find out the type of bridge that are suitable to use to accommodate the train load that will pass through it. Therefore, detailed procedure and analysis need to be carried out to ensure the bridge can last can use for a long time and have a low maintenance cost. So that is all from our groups. Thank you.